Welcome to Elixir Wizards, a podcast where we talk with software developers from around the world about the Elixir language and other modern web technologies. My name is Justice Epen, and I'll be your host today. I'm a software developer at SmartLogic, a Baltimore-based consulting company that has been building custom web and mobile software applications since 2005. From the SmartLogic team today, we have myself, Justice Epen, and my good friend, Eric Ostrich. Say hi, Eric.
Hello.
And as always, we have a guest on the show today, and today we have a very special guest. Today we will be talking about Elixir with José Valim, the inventor of Elixir. Say hi, José.
Hi, everyone.
So, José, we're going to start with a different question, but I'm going to throw a curveball at you because you might not have known that we've changed the name of the podcast from Smart Software to Elixir Wizards. What do you think of the name change?
Be
honest, José.
Okay. I'm a little bit on the fence, to be very honest.
Tell me about this. What's your opinion on
I mean, I saw the Smart Logic cards, and they are really nice. So, and they are building on the wizardry theme, right?
Yeah.
So, yeah, they are really, really nice. But I think, I don't know, this relationship with programming being magic, it's something that sometimes can be a little bit, I don't know. So sometimes people, they were like, oh, I don't know what it does. It's magic, right?
Yeah.
And sometimes people see it as a good thing, but I mostly see it as a negative thing. Sometimes it's used as a blanket criticism, like, oh, this thing is magic. It's like, okay, it's magic. What do you mean by magic? It could mean many things. Mm-hmm. So, but I understand that sometimes people say, oh no, we are wizards, or it's magic because it's the good magic, right? It's like the magic that makes things happen very fast, and it's reliable, and it's maintainable, and it does make you feel like a wizard, and that's a positive thing, but it does have negative connotations, in my opinion. That's why I was like, a little bit on the fence. So try to stay on the bright side of the magic there.
I think we're perpetuating a myth about the impossibility of learning technology, but I'm okay with it. Because I like magic. I like wizards as much as a nice guy. I grew up on Harry Potter. So, you're very famous in our community, José. So we wanted to ask if you would sign our GitHub repos.
Consider it done. I'm printing them, and I'm signing all the 200 pages.
Eric, I'll let you take the real questions.
All right, so let's we'll get started with some real questions. So when you start writing a language from scratch, what's the first step? Like, what was the first thing you started deconstructing?
Oh, that's very good. Let me see if I remember. So I don't have a computer science background. So my first step was actually figure out my first step. And then I started learning about tokenizers and parsers, which is kind of really the first thing that you do. So the idea of a tokenizer is that, because, we're programming text files usually, right? And then the words, the things that you put in a text file, they magically become software. So that's the word magic, right? And this is a long process, but the first process that we do is to break that file, which is, just characters, punctuation kind of stuff. We break them into tokens. So you can think like each variable name is a token, each operator is a token, but they are just tokens. There's no semantic meaning or no relationship between the tokens. It's just a stream of tokens. And then you have the next step, which is the parser, where we start defining some rules, like, an operator can, like a binary operator, requires something on the left and something on the right. And after you do that, then you have like a representation of the code. Usually it's a tree. That's why we say AST, abstract syntax tree. It's a tree representing the code. And then you have to do something with that tree. And then I think at the beginning I was actually evaluating the tree, which is super, super slow, but very straightforward. So if someone wants to kind of have like an exercise on how this would actually work in practice, what you could do is implement a calculator with these two chains. So something that receives like a number, an operator, and another number. You have to tokenize it, you have to parse it, and then that's going to have the tree, and then you have to evaluate the tree. And that's a very minimal exercise, but it covers a lot of the essentials on like building your own programming language kind of thing. I mean, I don't know if that answered the question. That was a very mechanical answer to the question. We can have a whole conceptual answer to the question, which is like, why would you create a programming language in the first place and where you started that level? But that's definitely the mechanical answer to it.
Yeah, I'll let you do my job for me. Why did you start? Because the next question was actually, you came from the Ruby on Rails world. And so maybe you could talk a little bit about your background working on Rails as a core team member. But then like, why? Why would you leave that awesome role?
Yeah, and actually, now that you said about smart logic and in being Baltimore, I think one of my first presentations ever on Elixir was, what is the name? It was, we had a kind of sessions at...
Was that BoConf?
BoConf, yes. I remember, I think it was you organizing the BoConfs. I think it was Smart Logic organizing the BoConfs for RailsConf in Baltimore. So that was like one of the first times I've talked about Elixir. At the time, it was still like the bad version. We're probably going to get to it. Like I built a prototype, but it was really, really bad. And I think like kind of did a presentation about it at the time. But yeah, so to answer the question, so yeah, I was involved in the Rails core team for a good period of time. And I like to say that what led me to eventually create a programming language, there are two main things. So the thing that I was struggling when I was working with Rails was exactly the idea about concurrency. We had a lot of people say, hey, we want Rails to run on all of the cores on the machine, because this started a little bit earlier before I joined the core team. We were having like this pressure from the community. Now we have a machine with multiple cores, and we want Rails to be able to use all of the cores in the machine. And in one of the early Rails versions, they released a thread-safe version of Rails. And thread-safe basically means, so one of the ways you can leverage concurrency is that you start threads, start multiple threads, like one per core, for example. And then to have these multiple threads, one in each CPU, executing the same code. And then they launched the thread-safe version of Rails. And so we could do that. But when that version was launched, what thread-safe meant was that there was a huge lock in your Rails application. So it was like, yeah, it's not going to blow up, it's not going to have any errors, but you're not really leveraging any of the concurrency because there is a lock in it. You can only process one request at the same time anyway. So there was not much point to it. But things evolved with time, as everything. And we were, and then I joined the core team. We were slowly trying to do more things concurrently, actually trying to leverage. And we would get like bug reports saying, like when I'm having a spike in production and we put up more machines, we have those exceptions. And it only happens in those scenarios, right? And those are usually very indicative of race conditions or bugs related to concurrency. Because if you think like when you deploy a new machine to production and some errors happen, you can think that what is happening there is that you have a bunch of requests at the same time, and then there is more chance that are going to trigger an error, some special condition that would happen. And of course, those bugs, they would be very hard to reproduce and consequently very hard to fix if we can't reproduce them. They are hard to fix. So I like to say that I think like most people, when they have a problem, they don't start with, I'm going to create a programming language, right? Because that's pretty much like, hey, let me give myself 10 years of work before I can actually solve the problem I originally had. So my initial intent was like, well, if concurrency is becoming more and more important, we need to find ways to solve this problem, right? Like we need to have better tools to tackle concurrency. So my initial idea was exactly to find out what are those tools and what we could do that would be different. And I say that in this process, like there were like 2 points of no return. The first point was when I found functional programming. And functional programming can mean a bunch of different things to a bunch of people. But to me, what it meant is basically the idea of data transformation instead of mutation, right? Because one of the issues we have with threads, like imagine you have like two CPUs running at the same time, and they try to change the same place in memory. That can cause, a segmentation fault, that can cause some sort of race condition. So with functional programming, because you're not relying a lot on mutations in general, this whole category of bugs, they disappeared. And I was like, wait, if I was doing this, like those bugs, they would have been disappeared, they would be gone. And that's usually the best way to solve a problem, right? If you can make the problem disappear, I'll take it. So that was the first point. And then there are many functional programming languages. And the second point of no return was exactly when I found the Erlang virtual machine. Because if you look at the languages over the last decade that started to get a lot of traction and attention, they all have a focus to tackle and solve concurrency, right? They all have this focus on concurrency, but that's not the focus of Erlang. In Erlang, concurrency is kind of a solved problem, and what they are really trying to tackle is distribution, and what they have effectively tackled is distribution. So, when you have all the code running on a single machine, using all the cores of that machine as efficiently as possible, but you still need more resources, what is the next step? Is to add more machines, is to make it distributed. So the Erlang virtual machine was always ahead of the curve for me, because while everybody's tackling concurrency problems, they are thinking about distribution. And then I was like, and I mean, there are many other great features in the Erlang virtual machine that you are aware of that made me think, when I write my next programming language, or my next software, not when I write my next programming language, when I write my next software, I want to target the Erlang virtual machine. And that was kind of how it started. And then I started using Erlang. I found things that I really missed in the language, and it eventually led me to create the programming language, create Elixir.
I want to ask a little bit of a follow-up question here, because you sort of touched on something that I was going to ask about, which is your discovery of functional programming, because you're coming from the Rails world, which is totally object-oriented, or at least pushes in that direction. What was it like for you discovering functional programming as a paradigm? And what was that aha moment for you?
Yeah, so I think a lot of my aha moment for functional programming was exactly the idea of transformation. And I just talked about this from the perspective of concurrency. It makes it very simple to write concurrent software because we solve a huge category of problems. But the other thing about immutability and data transformation that not a lot of people talk about is that it actually simplifies understanding of the code, right? Because when you're calling some code, you know that code is going to receive all the inputs and return all the inputs, right? And it's clear, like that's the only possible relationship. In immutable languages, you pass all the inputs, and that the thing that you're calling, that method or that procedure or whatever, it can return the output, but it can also change the input. It can mutate, it can change the input. So it's really hard for you to look at something and assess, like, what is the impact of calling this on my system, right? You don't know, right? And sometimes I understand, like sometimes people see that as a positive thing, but when you're talking about large systems and understanding how it works, that this thing like, when I'm calling this, it can do anything, or it can mutate anything, can mutate any state of the system. It's really harmful to understand what the whole system, the whole code is doing as a whole. So we're talking about Ruby, right? So you can call a method in Ruby, and that can change anything in the system, really. It can go to an external system. It can do anything. It can meta program. And I know a lot of people see that as actually a very positive, a very expressive feature of the language. But it can be harmful on the understanding of the code, like what that code is doing. It's hard for me to tell. With functional programming, I always know, right? It's always input, outputs. There is usually nothing happening underneath, no mutations, no sudden changes on the system.
So you mentioned you were, after doing some thread safe Rails stuff, you started looking around at other languages before starting Elixir. Like, what inspirations were you pulling from when you created Elixir, and like what did you borrow from different languages?
Yeah, so I like to say like the three most influential languages on Elixir, they are Erlang, of course, it's the first. And then we do get a lot from Ruby. So the syntax is Ruby inspired. Some of the naming, comes from Ruby, but most of the name, in my opinion, comes from Erlang because that's the platform we are running on. And the third one is Clojure. So some important ideas about protocols and like nested data structure traversals, like nil punning. Yeah, and a couple other things. I'm not going to recall them all, but they came from Clojure. So I think those would be the three main ones, but we also have a little bit from other things. So We do get some things from Python, for example, like doc tests. I don't know if there was another language that was before Python that did it, but I think Python is the most known about it. There are there are a couple things about. We got a couple things from Haskell as well, so a little bit from a bunch of different places. And
the follow-up question that I have is, you just talked a little bit about the languages that you drew inspiration from. I'm curious if you have any people that you look up to, that mentored you, that have served as inspiration to you over the years.
So I don't know, it may be my fluency in English, which is like, not my native tongue. Up to is a little bit weird, this relationship. But I would say that there is a lot of people that I have met and worked together through the years that I have really enjoyed and learned a lot. Going back to Ruby and Rails times, I can remember Yehuda Katz, for example. And even like I remember, so Elixir, we did a failed prototype, and that prototype, it was not what I wanted in many ways, and it left many open problems to solve. And some of those open problems was like how I want to represent and structure the language. So there are a couple open problems, but one of them I solved exactly with Yehuda Katz when I think maybe I was in the United States for an event or something like that. I was staying at his place, and then we were talking about those things, and we solved it together. So there is Aaron Patterson, Tender Love as well. We are still good friends. We talked recently about ideas, optimizations, or life in general. So those would be, and there are probably others. I'm not going to remember everybody. And even now, like, there are people that I talk to in the Elixir community frequently, and it can be some kind of like a up-to relationship from time to time, but I hope that sometimes it's also the inverse. So that's why I didn't want to say like up to, because it implies some kind of relationship, but like sometimes, so I talk a lot with Chris McCord, right, from Phoenix, and sometimes he has really amazing ideas. So I still, like, at the very beginning, when this is like 2014, we were starting to have a bunch of like web frameworks in Elixir, and I felt that all of them like were kind of missing something. They were all trying to, I feel like in a way, they were kind of like my first Elixir prototype. They were like, like, I want to use this technology, but I'm not sure how. So there were, so like there was a sort of mismatch. It didn't feel like everything was fitting together. And with Phoenix, it was the first time I had this impression. I was like, oh, everything here, like we have new, fresh ideas, and everything fits together. So like the simplicity of how views are implemented in Phoenix, it was one of the things that it was Chris' idea, and I remember really being fascinated by how simple the solution was, right? The fascination was not with the complexity, but actually with the simplicity. Look, it can be this simple. And other team members from the Elixir team, I'm lately working a lot with Eric on a couple things, and it's really good. We have long conversations and we learn a lot from each other. So yeah, I feel like I answered the question. Yeah.
You mean Eric Meadows Johnson?
Yes, thank you.
Okay.
I didn't want to take a risk of pronouncing his name and get it wrong, so I'm glad you took the risk for me.
Oh, I'm happy to take the risk of mispronunciation. Have I ever told the story about Eric patching Hex for me on the show?
No.
Eric, so like a few months ago, we were having an issue with uploading packages to Hex because of the HTTP timeout that's built in, and the terminal command flag just was broken. Like it wasn't actually changing the timeout. And within like an hour, Eric diagnosed the problem and fixed it and pushed it up and solved that for me. And I was just really impressed by his helpfulness and generosity of time, and his willingness to patch an open source library sort of on the fly to help someone get something done. So Eric is a really good guy, and I hope that we can have him on the show this season. So I'll let our Eric here, who I do literally look up to, take the questions from here.
All right. So you've mentioned in past keynotes at like ElixirConf that you're kind of transitioning to an R&D phase. going forward. So I guess like when you're doing that, like, do you have any particular strategies for like reading through other languages or libraries or whatever to like take ideas and bring them back into Elixir?
Yeah, so that's precisely it. And when I started with Elixir, it was kind of the same. So I would read a lot. I would usually not go with a lot of depth, but I would really go for the width and just try to absorb different ideas, different approaches of how people are doing things. And those are in different ways. Sometimes it's just reading, online material, but most of the time those are rather papers or books. And yeah, and then I would read and I was thinking like, I would be reading and assessing things at the same time. Like, wait, like, would this apply to what we are doing? Is this a problem that we need to solve? Would the Erlang VM or the Elixir language be good platforms for solving those kind of problems? So it's very exploratory in nature. And then I kind of narrow down to a list of things that I think like are worth trying, and to the different levels of complexity, gains, how much time and effort would have to be put into it. And then hopefully with time, I start tackling those and validating those ideas a bit more. And then they slowly get a little bit more concrete, or they go to a couple rounds of prototypes. So one good example of this process was actually Gen Stage. So it was pretty clear to me that the Elixir and the Erlang virtual machine can be a very good platform for data processing, but we didn't have the tool. So one thing was already out of the box, like checked, like, oh, can the platform be good at that? I was like, sure. We just need to figure out how, but I'm 100% sure it can be good for it. And we did 3 or 4 prototype implementations until we ended up setting down on Gen Stage. Right. And that's the story that is still going on today. So we had Gen Stage, then we built Flow, which is more about data aggregations and think about data as a whole. And now we have released the Broadway library. Platform Attack. We released the Broadway library, which is about data processing, but for a more operational perspective and like working with queues, getting stuff out of RabbitMQ, Kafka, Amazon, Google Cloud, and so on, and transforming this data. So data pipelines. And it's still something that keeps on going. And, at some different types, we have different kinds of research or investigation or different problems to explore, but they kind of go through this similar process, which is a little bit chaotic, but it's like a nice chaotic. It's kind of, being a little bit in the dark, trying to figure out what is this, right? What is happening here, and moving from there.
So we're going to dive a little bit more into sort of where the language is heading. But before we do, I'm curious sort of about your personal work habits. What does your workday look like? How do you get into flow? When do you get started? How much of it is conceptual, like in your head on paper, versus like actually programming and hacking?
Yeah, so I was used to have a flow, but now I have 2 kids and one of them is still at home. So there is no flow. Hopefully, when they're both back at school, I'll be able to establish some kind of a routine. But right now, everything is just a little bit too chaotic. But one thing that I have done for a good period of time is to kind of leave work, like when I'm done with the day, I try to spend some amount of time, doesn't have to be a lot, can be 5 minutes, can be 15 minutes, thinking what I'm going to do on the next day. And sometimes it works really, really well because I already started thinking about the problem I have to solve tomorrow. So, sometimes I'm brushing my teeth or I am in the shower and then I can have ideas. So I take notes. If I'm too excited about that idea, I would actually go back and work. But it usually helps like just have my mind in the proper mindset. Like tomorrow I'm going to do this. And I think it's also very effective against like just procrastinating, right? Because sometimes the hardest part of starting a new day is like starting work. Usually after you start, you're like, okay, now I'm going, right? Or unless you finish the task and then you're like, oh, now I can finish another, I have to start another task. And then you can always fall to the small temptations in life, open a website and start reading and kind of lose track. So I think it helps a lot with keeping this flow, just like, oh, here's what I'm going to do next, or here are the next things I'm going to do. And I kind of like hype myself like, oh yeah, I want to do that, or I have to do that. And that's really helpful. And the other thing is that I usually turn off all the notifications. So there is no way for you to interrupt me unless it's urgent. And I think that helps a lot for me to stay focused.
Okay, I hope that all of my colleagues are listening because I'm turning off all my notifications.
Do it, yeah.
And also, I guess I'll just say congratulations on having 2 children. I think that's a tremendous blessing and just very, very cool. And being able to be at where you are in your career and have kids and the whole package. I know that everybody who's a fan is very happy for you. So,
oh, thank you. I appreciate it.
All right, so we'll end, I guess, this little section with a kind of a fun question. Do you consider yourself an Elixir programmer? Like, I think I've heard Matt say that he doesn't consider himself a Ruby programmer because he's so in the weeds of like the C that makes Ruby work. Like, are you so in the weeds of Erlang, C, or something else that like you wouldn't consider yourself, in quotes, an Elixir programmer?
Oh yeah, I'm definitely an Elixir programmer. So if you look at even at the Elixir repository itself, it's like 95% Elixir and like maybe not 95, but really close to that, and 5% Erlang. And I would say that does reflect in general, like how I've spent my time writing code or reviewing code or checking out code. So yeah, I am more on the Elixir side of things for sure. There was a month this year where I actually wrote more C than any other language, or maybe I didn't. It just feels like I did, but that's definitely not the standard.
So we're going to move on to some sort of performance related questions. You're probably aware this is our 3rd season now of the show, and we've had a theme in previous seasons. The first theme was Elixir in production. Season 2's theme was Elixir internals. So we talked about a lot of sort of like the internals of various libraries and whatnot. This year, we're going with the theme of working with Elixir with some sort of subtopics under there that are like performance, functional programming, training, that kind of thing. So we've got a section of performance questions here. And I think the one that really is burning a hole in my head is this question of like, why are we not using Elixir for machine learning? Because it's so performant, and every time I've heard people say, they usually chalk it up to like some sort of issue with computational performance, but I haven't actually seen any real benchmarks that support that position. So I'm curious like what your thoughts are on performance and why we're not using Elixir for machine learning yet.
Oh yeah. Yeah, so our performance is definitely not good enough for machine learning in general, but it doesn't matter because most other languages, they're also not good enough. So like take Python, we're probably at the same ballpark as Python, but Python is excellent for machine learning, right? And the way that Python does it, I mean, there are like some fantastic, there are a couple layers to this, right? But the way that Python does it, they're calling C or they're calling Fortran. They are relying on established, libraries, established patterns, and that's what they use. So we could totally do the same, right? But, we will be depending on third-party code or code written in C and Fortran or something like that. And it's completely fine. So you can totally do it. We do have, however, a reason for not having not a head start, but for not having a start on this is because we didn't have a lot of ways of running up until, I don't remember exactly the LTP version, but let's say 18 or 19. We did not have a lot of way of integrating native code easily. It was not straightforward. It was not straightforward to talk to a C library. We could, of course, talk to a C library as an external program. That was totally doable, or using IO or something like that, but not talk like to C natively. And this has been solved for the last, I want to say, 4 or 5 years. So since then, I feel like in a way we have like no excuse in terms of technical limitations, right? Like it's a problem that we can it's a problem that we can solve now technically. Yeah. So that would be like my answer to this. Like, I feel like, yes, we're not fast enough, but it doesn't matter. Like the other languages are not necessarily fast enough either, but they are really good at that. But I do want to make the remark that there are a bunch of like fantastic projects in Python that helped, even if you're not relying on C or Fortran, they help make it really efficient to write now computational code. So there's like, I don't know how to pronounce it, Cython, which is C with Python. So it's like, it's a superset of Python that compiles to C, and a lot of libraries use it to make it really straightforward to write C bindings to something. So it's a really interesting library, and it can give really important performance benefits. There's like the Numba, I don't know how to pronounce it, NUMBA project that does JITting and convert things to like GPU computations that sometimes like can be 100 times faster than regular Python. In this case, it's just compilation techniques, right? It's not like you're writing C or porting to C, but some library that can look at some very specific patterns on the code and do a very efficient optimization. So, but yeah, I think it's definitely doable. That would be my answer. And there was a talk at ElixirConf from Jason. I'm not going to attempt to pronounce his last name. We can add to the links later. Jason from Dockyard, but it's exactly about machine learning. The library was called ANEX, and he has some thoughts on machine learning in Elixir as well. And there are some interesting things. For example, like there are some of the algorithms they are implementing in terms of machine learning. Like imagine that you want to identify if something is a cat, like a picture. There's a cat in the picture. And you usually don't identify like this is a cat. You usually assert features like, oh, does it have a cat-like ear? Does it have a cat-like nose? Does it have a cat-like mouth? So you train for those particular specific features. And one of the things that you want to do is that you want to train like a bunch of neural networks together. So you maximize the decision of those different features together. And so there are libraries that do that, and they do that in a distributed fashion, right? So they are all they're running on different machines and all coordinating and trying to get to this maximum point together. And, and it would be like just fantastic to write. Like if we had the background, if we have the basic tooling, like implementing those kind of algorithms that need to reach out to this consensus together would be so straightforward in Elixir, right? Because they're running virtual machine that it would I would love to do that. But we just need the foundation. So yeah, so I know that Jason, he gave a talk on ANEX and he's exploring those ideas. So it's worth checking that out. But yeah, I think we can do it. We're not technically limited to do it.
All right. So the first step in, I guess, making things go faster and getting better performance is measuring what you currently have. So like, what kind of steps do you do to be able to measure the code you're writing?
Yeah, so there is the Benchy library. So yeah, so usually performance, first step is we need to benchmark and see if that thing is actually slow or fast, or sometimes it even helps you benchmarking is enough to isolate a piece of code. So one of the things that I like to do is let's get a Phoenix application. I can either benchmark with Benchy, or I can benchmark using some external tool, like command line tool, like not a patch benchmark because sometimes it's unreliable, but WRK, something. There are a bunch of different tools. And so I start benchmarking, and one of the things that to establish the baseline where I am right now to see if things are slow. And I use those tools. And also while benchmarking, I usually try to remove code. I start randomly remove code and see how it affects benchmarking. And then if I remove some code that makes the benchmarking much faster, then I'm like, okay, I'm getting closer, right? So I'm playing hot code with it until I get to some piece of code or to some part of the code that is hard to say, don't run this. That is, it's a chunk at its whole that I have to understand it as a whole. And yeah, and then I would benchmark until I get to this point and say, okay, this is now my new baseline. Like I have this part of code that I know it's slow. And then I would move to the next step. And the next step would be usually profiling. So you can use the tools that ship as part of Elixir. So we have like cprof, eprof, and fprof. So then I would and then the profiling usually tells you more information about what to fix next. And then it's kind of an iterative cycle until I maybe find the bottleneck and I solve it. Then I go back to benchmark, see if the numbers actually reflect on the reality, and do a couple rounds of those until I am happy with the result.
So can you talk a little bit about how much time you've actually spent on specifically working on performance issues in Elixir?
Actually, that's a very good question. It's not very frequent, to be very honest. And it's kind of like I love performance things. I love like if somebody comes and say like, hey, this thing is slow and I can prove it's slow, I'm usually excited about the challenge. I find a challenge to have something slow and make it fast. That's why I like it. So it's usually, I'm really excited to do this kind of work and optimizations and try to understand why things are the way they are. But fortunately or unfortunately, it doesn't happen that often. So I'm not even comfortable with being giving like an estimation of time because it's not frequent.
All right. So our last question about performance here, is there any, I don't know, stories or things that you do that you might have had to compromise in terms of how the code looks or acts or whatever in order to achieve performance?
Yes, definitely. So, and it depends on the level. So I would say there are like 4 kinds of levels in this. So there is, and I do work on the 4 levels. So I would say there is like the language level, there is the framework level, there is the library level, and there is the application level. So the lower you are, I am personally okay with writing ugly code, let's say, in sakes of performance, because I feel like I should write me and the Elixir team, we are like 5 people that we should maybe write the ugly code. So thousands, dozens of thousands, I don't know, hundreds of thousands of people do not have to do that. And then I think frameworks can also make similar things, make similar compromises. Sometimes rely, on meta programming, which generally you shouldn't, or rely on those things a little bit more so we can achieve that performance. And then libraries as well, but usually more contained. And then application code only if I have to. And it's usually, I would leave very explicit remarks on why we are doing that and usually come up with a plan so we don't have to do that permanently. So those 4 different levels, I'm really okay with doing it at the Elixir level if necessary. But yeah, and then as we go up, I hope we have to do it less and less.
So that's a really good point to end on. We want you to have some time for any shameless self-promotion. But before we do that, our very last question would be, what's in the future for you and for the Elixir language?
Oh yeah, so for Elixir, and that was one of the topics on the keynote at Elixir Conf this year, like all the features that we had planned for the language, they are in. It doesn't mean that we'll stop working on the language, like we'll continue to release new versions twice per year, and we have like some nice features already planned for 1.10. It just means that like the backlog is empty, right? So we'll continue improving things as they come, but let's say the next big thing is not going to be there in the language. And this is kind of true for a while, because if you look at the Elixir releases, we had 1.6 that was kind of big because it had the code formatter. So it had and code formatter was a good amount of work. And then 1.9, and then we had 2 other releases that were kind of oh yeah, it has nice features, but it's nothing out of this world. And then we had 1.9, which had releases, which was also a significant effort. But so you can see there was already some cadency, if things were already slowing down, and we are at that point officially. Yeah, so the focus is not there. So to me, there are a couple things that I am excited about. So I am excited about LiveView. I'm not actively working on the project, but I do have conversations with Chris, and so over the last weeks, we were working together on this feature called components that is going to make it easier to structure our code, and it also has very fantastic performance benefits to LiveView. So that's kind of exciting, although I'm mostly following that up on the side. With my team at Platform Attack, we are continuing to evolving Broadway. So as I said, at the beginning we had Gen Stage, and Broadway was kind of the next evolution to Gen Stage, which is more structured for working with data pipelines. But we also feel there is a next step on this evolution. There is a third Pokemon in there that we are trying to figure out who it's going to be. And that's very exciting. We're putting a lot of cycles on that and trying to see how that thing is going to look like. And hopefully next year we will have something to show. We will see. And yeah, the other thing that I am working on, not really working on, but following, is the work of Eric from the Elixir team, right? So I mentioned at ElixirConf that Brex hired Eric to work on the problem of code analysis of Elixir code bases. And basically what we want to do is like, well, if we look at a code base, what can we know about this code just looking at the code, and what can we find that is important? And yeah, so we do talk a lot about those things. So I think those would be like the three main fronts that I am like kind of interested right now, and working together and collaborating with various other people at different degrees. And I'm excited to see what we're going to have next.
Super duper. And do you have any plugs or asks for the audience before we let you go?
Oh yeah, I do have many plugs. There is like plug parsers, plug session. I'm pretty sure I wrote all of those.
How has that joke not happened on this show yet?
Oh wow. Yeah, first time. Yeah.
That's the first. Yeah, good job.
Yeah, not really. I feel kind of like a plug what I'm excited about. Well, and there's always the company, right? So I am co-founder of Platform Attack. We are the company behind Elixir, and we have this service called Elixir Development. And we do two things, right? So we do, software development, and we also have the service. So if you were at ElixirConf, you heard about it, which is called Elixir Development Subscription, which is a direct line between our engineering team and your engineering team. So if you have any questions, support, you can just reach out to us. And the Elixir Development Subscription experience has been really fantastic for me and my team at Platform Attack, because sometimes having like this kind of hands-on experience on the challenges and problems that different companies are having, it's really invaluable feedback. So for example, Broadway, it was born because we were helping many companies establish the gen stage pipelines. And then they were running into common pitfalls. And they were like, you know what? And then we would review their code, we would work together with them, like, oh, have you considered that? Have you considered this? And those things, it's not like, oh, it's a secret, and we would not tell anybody, right? It's not a secret. We would talk about all those pitfalls in the docs. It's just that it's probably gen stage as an abstraction was too low level when you want to establish a whole topology of data processing. So work with them, we felt like, hey, I think there's something here, right? Like that was the first time we realized that there was like the second evolution there, the Pokemon, which came up to be Broadway. So yeah, and that led to even more things now. So we're working on the third. Yeah, so I think that those would be my plugs. It has been really more work related, and it has been really rewarding. And then if you want to work with us, if you want to work with my team at Platform Attack, go to our website, reach out to us, and we would love to talk.
Well, thank you very much, José Valim, everybody, the inventor of the Elixir programming language. This has been another episode of Elixir Wizards, Season 3, working with Elixir. My name is Justice Epen, joined by my co-host, Eric Ostrich. Thank you very much, and see you next time.